Hello, hi, welcome to you all to another Etabs 2015 tutorial video. This is my third tutorial. If you have not seen my first and second tutorial, don't worry, watch it later because I'm going to show you again how to draw a structure based on IS standards of Indian. The Indian IS code method I am going to show you fully today using ETABS 2015. So to know how to start the ETABS 2015 in basic mode, go to the episode 1, that is tutorial 1 of ETABS 2015 playlist. That is in the description below or on the screen now. So let's start with making a model again because I have lost that model which I have created because I have did so many experiments on that model, and I, I want to create it again to show you how to do all the procedures. So be ready to like and subscribe. Uh, be keep login to comment whatever you have questions on ETABS 2015. I will try to solve it, and whether you what you want to learn from me, you can comment below. So thank you for listening all those things. Now let's start. So we'll start with the new model. So new model, whatever uh, set that is for metric SI system, I am using Indian code. I'm using IS 800 2007 for steel code design code. That is not required for now because I'm going to show you concrete design. So IS 456 2000 is a code for concrete design. So be ready all these things. The model initialization is ready. So now I'm going to show you how many floors and how many grids we require. We can give it here. So number of lines in the x direction. So let us take this time the number of lines we 5 and 5 in each direction, and 6 meter and 6 meter. Let the number of stories be 5 and the bottom story height be 3.3. All these things are set. Check this is on grid only. Okay, now press OK. The model will appear after creating it properly. So the model has appeared. So viewing model on wide screen I don't like because I don't like to work on the wide screen because it affects eyes so much. So I'll be doing again graphics, display color, then I'll be taking it as black background. Press OK. So the background will be black and it will be smooth to your eyes to see everything what is there inside. So you can see there are 5 grids: A, B, C, D in X direction and 1, 2, 3, 4, 5 in Y direction. The grids are so these are parallel. 1, 2, 3, 4, 5 are parallel to X axis, and A, B, C, D, E are parallel to Y axis now. So this is only the grid. The building is not ready yet, but you can see the 3D model of the grids beside this. So now we will be working on this plan view, and this is the story 5. So you be sure that on the left, on the right, below bottom corner, you should select one story to similar stories here. Then start doing the work because everything you want to do on the floors here. So first you have to give the material properties. So 3 material properties are also already mentioned. We have to add a new material with India, and first start with concrete, Indian concrete. Let it be M30 only. Okay, no other material. M30 everything is okay. Specify the unit volume. M30 everything is okay. Another for beams and slab, I want to add a copy of it. No, cancel, not a copy of it. I want M25 to be the for beams and beams and slabs. Okay, everything is set. Press OK, and then rebars, Indian, not that is concrete. This is rebars. So in rebars, HYSD 415. Now we are using mostly HYSD 500 grade on site. So we'll be using taking this one as all things are set as usual. Press OK, and these things are set now. So we can use these things, and we cannot delete these things. These are already mentioned materials. So let it be. So three materials we have mentioned now. Now we are going to provide the section properties. Section properties for beam and column can be given in frame sections, and for slab sections or deck sections you can give this for slabs. Okay, let it start with frame section. These are all frame sections available already in this. So delete multiple, select all, select all these properties and delete selected frames. Okay, two will be remaining. So add a new property, concrete rectangular for as code of beam. Let it be a beam of that is 230, not 230. Let it be 300 by 300 by 600 beam. Let it be. Okay, so this beam will be, the depth is 600, width is 300. I am keeping, and this is beam. So the modifiers, this time I will be showing you how to give the modifiers. The three things we are going to change in the modifier, that is 0.01 for torsion, because torsion is very less, it will not be taking any torsion, and 0.35 and 0.35 for beam for moment 2 and 3 axis moment of inertia. And let us see the modify rebar. In this we will be selecting beam only, and here we are using HYSD 500, and top and bottom bars. The cover to the top and the bottom bars for the beam is 25 mm or 20 mm mostly, but it is to the centroid, so we are giving 25 for the safer side. Okay, so all the properties have been set for the beam, and here you have to give the beam concrete as M25, and you can change the color also, not required. So all these things are set. So these are beam. So another property we can add is column. So add a new property, concrete, select it as M30, and this time we will name it as column, COL, and the column we are taking just 600 by 600, just for easy task. For G plus 4 it will be sufficient to take 400 or 300 by 450, but just for the safer side, for explanation purpose I am giving this. And the modifiers will be this time, oh, before the modifier, sorry, it should be 600, depth is 600, width is 600, and the modifiers will be changed to 0.01 for torsion, 0.7, 0.7 and 0.7 for moment 2 and moment 3. Okay, and the rebars will be using column only, P M2 M3, and designed reinforcement to be designed, rectangular ties, all these are set. And you can use 20 bars all around, or you can give how much bar you want. 16 bar will be sufficient. uh, and you can give 5 in every direction, 5 in this direction, 5 in that direction. And the confinement bars is 10 okay. So all these are set. Column is set, beam is set, column is set. The next thing is we are going to define the slab section. Go to the section, slab sections. Okay, we will be deleting this blank property, and in slab 1 we will be modifying it to M25 shell thin or membrane. We can take anything, we can take uh, shell thin or membrane distribution, anything you can take. Let it be shell thin only, no need to modify. And the slab thickness is slab, let it be 125 thick. Okay, the self weight will be taken by itself, so no need to give the self weight to these slabs. So no need to worry about the self weight, it will be designed by itself. So 6 meter by 6 meter slab, so how much the things will be required. So now we have defined these things. Now we are going to draw. So, we are going to draw now all the beams and slabs. So for quick draw beams, use this one. I'll go to draw command. In that you will find draw frame and beam, and in this select as beam, and it should be continuous. I can drag from here to here, and all the beams in the similar stories have been drawn except the ground floor beam. So the plane beam will not be drawn in this. So that is the case we have taken similar stories. So we need not to draw every time, it will draw by itself. So now we will draw columns. We will select this quick draw column, and then we'll select it here, the column cursor. We will select the property to column, and now we can keep column one by one, here, 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 or we can drag and see the columns are drawn. So we have dragged it, and the columns have been drawn. So next what we can do is, columns are drawn, beams are drawn, we can give the slab sections by drawing one by one slab or drawing directly quick draw slabs. And here selecting the slab one or the opening, or many properties are there. In the property we are selecting slab one, and we can just drag from this side to this side, and the slab is drawn. So for doing any analysis purpose, we should keep these supports to be fixed, and for just doing design we should keep it as same pin jointed self. The pin jointed is not uh, really possible on the site. It is required different reinforcement details, and the pin jointed footings should be designed separately. So we will keep it for fixed design, for simple and simple tutorial, for making it a simple tutorial for you. I am keeping it as the bottom footings. I am keeping it as fixed support. So how to provide the fixed support? You have to go to the okay, so you have to go to the bottom floor. Just press this move up button, and you will come to the bottom floor. And now you drag like this, and you will be selecting the points on the bottom. And now go to assign, joint, restraints. In this, you select this one as fast restraint fixed one, first one, and you apply here, press OK. Now you can see in the elevation that these supports are now fixed support. Okay, so next we have given the slabs, we have given beams and columns, everything we have given. Now we will just give dead load and live load to all this building. Come to the plan view before, okay, doing that. So we will be giving dead loads and live loads to the building. So I'll just give load patterns. In this we have load cases. So already dead load is given as self weight multiplier 1 and live load is nothing. So just leave it like that. We don't need not to modify anything. And in the load cases we have linear static, live load, linear static. These are okay. We are okay with it. We'll go with the load combinations and we will give a new add a new combo, that is combination 1.5. Yeah, so in that linear add we will be adding dead load 1.5, uh, and to that we will be adding live load 1.5. So this will be combo 1.5. Another one, uh, dead load plus live load. This is service, this is collapse. Okay, this is compatibility conditions for collapse. This is the load combination for collapse load, and one is service load. That's for service load, just linear addition of one. So com one we will be keeping as dead load one time, live load one time. Then okay. So com1, com2, two combinations have been defined here. Press OK. Then give the mass source if you want. Uh, Provide the mass source, as it will be required for the later cases when we will be going for earthquake loader and everything. So mass source you modify it, and for mass source you go for, okay, dead load, live load. I'm going to give you it as one for dead load, and live load is 0.25 times for up to 3 kilonewtons load on the floor. So that's okay now. So this mass source is set. Then model cases, it will be required for the uh, earthquake, again earthquake loadings and all those things we are not doing in this tutorial, but we will be doing in the next tutorial for the earthquake loadings, how to find the response spectrum and all those things. So rates is much better, but we'll be using it to keep it as IGN only. And in this we are using mass source as a mass source 1, which we have defined just now, and we will be keeping it as, we have 1 2 3 4 5 columns, this side 5 5 25 columns, and 1 2 3 4 5 floors, so 6. So 5 5 the 25, 25 6 is it's 25 6 150, so nearly. I'm going to give it 200. Number of modes, minimum number of modes is this, so I'm giving the model as 200. Okay, more is the modes, the more nearer the value will come. uh, so the more iteration it will do, and the answer will be very nice for you. So next we are going to give the loads, assign the joint frame loads, right? Okay, assign the frame loads, there is nothing but the wall loads. uh, okay, wall loads what we are going to give on the beams. So you can give to the beams by selecting go cell and select to the properties and frame sections, and you select beam here, select. So all the beams got selected, and you go to assign. Now go to frame loads, distributed load, and in this you give it as a dead or alive. It is dead load, it is forces not moments, and it is a gravity load, and the is load is 5.25, mostly 5 point, yeah, 5.25, 5.25 for the interior walls, and for 5 that is 10.5 for the exterior walls. Mostly after neglecting the depth of the beam, you can find by taking the brick weight as 19, brick density as 19 kilonewton per meter. So like that you can calculate. So apply. So to all the beams it has got applied. You can select different beams for giving different loads to the exterior beams, that is 10.5. So we are okay with it. Okay, now close. So we have got the loads on the beams. Now we will giving the live load on the slab. So select all the properties, go to slab sections and slab 1, press select, and give assign shell loads, uniform load, live load, because dead load we can give 1.5 and live load we can give. Okay, so first we will give the dead load maybe 1 kilonewton or 1.5 kilonewton per meter cube. Replace existing loads, apply. Okay, so again previous selection, or select this slab, select and assign again shell loads, uniform, this time live load, and give it as 3 kilonewtons for exterior beams or interior. So up to 2 kilonewtons is enough for the residential buildings. Press apply. Okay, close it now. To see that all the loads have been assigned properly, just right click on the panel and go to the loads, and you can see the dead load is 1 and live load is 2 has been assigned to this slab panel. And you can right click on the beam to see the loads here. 5.25 is the load assigned to this. Now we'll just check the model, is the model is ready or not. Select all the things here. Now the program is analyzing the model, is there any errors or not. We have to wait for some time. So the no errors have been found, the model has been checked. Okay, we are clear to go with our analysis. We can do analysis now. So before doing analysis, go to select all and assign shell as a diaphragm D1. So we need not to do any meshing to the structure. It will do by itself using this diaphragm D1. We can also see what is the diaphragm mentioned here. You can go to the diaphragm in the define menu. It will pop up another window with diaphragm D1. We can check what is the diaphragm D1. It is a rigid. So we can give rigid or semi-rigid. So our diaphragm is rigid. Press OK. Okay, everything is set now. Go to analyze, set run load cases. Now we are going to run model, dead and live load cases. So everything is set to run. You can set it as run, do not run, whatever you want to run. If you want to just see the dead load and live load separately, you can run dead load first and then live load later. Separately you can do, and we can see the movement diagrams for separate cases differently. But we are going to run all this thing now. So run now. So analysis, before analysis we have to save the program. Let it be tutorial. Not here. I'll be saving it in E folder. Make a new folder. Tutor. Okay, tutorial. In the tutorial, name it as test is code. Okay, save. So we have saved the file. The file has been saved. The model has been used analyzing for this test and the preparing for running analysis. And this is going to run here like this. And it has been run, refreshing the window, and this is the diagram after analysis. So you can see this is a dead load case, this is a live load case, and can start animation. So there is no earthquake load in this. You can see this is only in the upward and downward direction the movement is. For both live load and dead load, you can pin on any corner and you can see how much is the deflection at every point of it. The structure in the central part, it will be much deflection in the user direction. You can see 1.9 mm, so it is less than 10 mm, so it's okay for Indian car. So next we have to see, go to display and go to the stress load diagram, and you can go to these. In this you can see the movement diagrams for dead load. Okay, and you can apply, and you can see the movement diagram here. And another, you can see the shear diagram. Apply, you can see the shear diagram of the building. Shear 3 will not be there, moment 2 will not be there, so moment 3 is mostly what we required, and shear 2 is mostly what we require. Axial force is always okay. This is the axial force increasing the column, you can see in this. So whatever. So you can see the deformed of the combination 1 here by going to the display, deform shape, or by clicking this button here. You can see going to combo, by pressing combo 1 you can see this animation for the combination of dead load plus live load, and 1.5 you can see there is much deflection for 1.5. So by closing now, we are going to conclude this tutorial for today. So in the next tutorial, we are going to um, design this using the design concrete frame design here. So this is a one just only one step, so we can do in the next tutorial. And in the next tutorial I'll be showing you how to design the concrete building, and what are the conditions we have to set for the building before designing it, and how to do detailing of the concrete building, and how to see the details of the building uh, for beams and columns, everything on Etabs 2015. Thank you for watching this video and making it to the end. Thank you so much. Do like and share this video with your friends and colleagues for their learning purposes. Thank you. Bye bye.